Hi folks, we're going to do a little speed run of this Chapter 7 review for your Chapter 7 assignment from Math 621B. So in 1 we're asked to evaluate 2 cubed, it's just 2 times 2 times 2, so that'll give you 8. When you see 4 to the negative 2, a negative exponent tells you to flip. So this would be 1 over 4 squared, or 1 over 16. Anything other than 0 to the power of 0 is just 1. And then D has a bunch of stuff in it. It is telling us to flip, because it's a negative power. It is telling us to square root, because that's the bottom of the fractional exponent. And it is telling us to raise it to a power of 3. Okay? So if we show all that stuff, which you don't necessarily have to, that means that we're square rooting and power of 3, which would be 1/2 cubed, or 1 over 8. Number 2, write the equation of the asymptote on 3 to the x minus 2. So if I started to graph that, the first thing I would do is I'd move my asymptote down 2. And that gives me the answer to this question. It's going to be at y equals negative 2. We're solving in number 3, so maybe I'll just get a little space off to the side here. 3a, we have 2 to the x minus 2 equals, we need a common base here. So I'm just going to rewrite the number 8 as 2 cubed to the 2x plus 1. Okay. And now we're just going to get rid of some brackets, so that just means multiplying our exponents. That'll give us 2 to the 6x plus 3. Okay. And we can now drop our exponents. So x minus 2 equals 6x plus 3. And I could move my x's to this side and my numbers to this side if I wanted. And I'll get x equals negative 1. Okay. If we really wanted to, we could double check that that is true, and it will give us the same amount on each side. In 3b, same sort of idea in 3b. Where can I jam this? Maybe I'll just put it underneath this one. 3b, we've got a 9 and a 1 over 27. So if it were me, I would pick a common base of 3. That's 9 is 3 squared to the 2x plus 1. And 1 over 27 is 3 to the negative 3. It is a 3 that has been cubed and flipped. And now we're going to do the same thing. We'll just get rid of our brackets, so that'll give us 3 to the 4x plus 2 on this side. And on the other side we'd have, and it's easy to make a little goof here, 3 to the negative 3x plus 6. Okay, hopefully I haven't done anything silly. I'm going to drop my bases. I have 4x plus 2 equals negative 3x plus 6. And then that would give me 7x equals 4 as I move things around, or x equals 4/7. I'm going to go check that answer just to make sure I haven't done anything silly. That's great. 3b is 4/7, and 3a is negative 1. All right, number 4, sketch showing 2 points in the asymptote. So in this one, first one, I can choose any x and y values I want. I just think 0 and 1 are going to be easy x values. And if I put in 0, I'll get, so this will be 4a. I'll have negative 2, 3 to the 0 plus 1, or negative 2 times 1 plus 1. That'll just give me negative 1. Okay. If I put in 1, I'll get negative 2, 3 to the 1 plus 1, or negative 6 plus 1, or negative 5. Great, those are 2 points. I don't have to use those 2 points, but they're going to work out just great. If you use different points, excellent. Okay, and we're going to go ahead and move this asymptote up 1, okay, because that's what the plus 1 tells us here. And I have this point at 0, negative 1, and I have this point at 1, 2, 3, 4, 5, 1, negative 5. Those are 2 out of infinitely many points that you could have chosen. And I'm just going to connect them together in an asymptotic banana. And there we go. Okay, B, same idea. We've got x and y points to choose. I really wish that this exponent here, I would really like to make it a 0. That would make my life easier. So I'm going to choose negative 3 for x. That would give me 5 to the 0 minus 3, or 1 minus 3, which would be negative 2. Similarly, if I made the x value negative 1, I would have 5 to the power of negative 1 plus 3, so that's 2 over 2 minus 3. In other words, I would have 5 to the 1 minus 3, or just 2. Okay. Those, again, are 2 out of infinitely many points that I could have found, but I think they're pretty good ones. Okay. And in this case, we're going down 3, so that's where our asymptote is. I'm going to figure out where these 2 points are, negative 3, negative 2, there we go, and negative 1, 2. Okay. And I'm just going to draw in this asymptotic banana shape. Okay, let's see if those look pretty good. Yep, those are the same points that I chose for my answer key, but we could have had other ones. All right, find the x-intercept of, sorry, we're forgetting one here. Number 5, find the equation in the form y equals c to the x plus k. So I can see that this has an asymptote at x equals 1. It gets really, really close to it, so it looks like it's on it, but if we really zoomed in on decimals, it wouldn't be. That is telling us that k equals 1. So now we know that the equation is c to the x plus 1. And if I can just pick one other point, I should be able to find the equation. And here's a point right here, negative 1, positive 4. Okay. So I'm going to sub that point in. For y, I'll put in 4. For x, I'll put in negative 1. And I'll just work on getting c on its own. So I'll move the 1 over to the other side. C to the negative 1 equals 3, or 1 over c equals 3. And either through algebraic manipulation or just sort of reasoning it out, if 1 over c is 3, then c is 1/3. And that means the equation is going to be 1/3 to the x plus 1. Okay. If you decided that you wanted to write it as 3 to the negative x plus 1, that's okay. It's not the form that it's asking for here, but I would still take that. Number 6, find the x-intercept. If you're looking for an x-intercept, if you're on the x-axis, what you know is that y is 0. Okay. So I'm just going to sub in 0 for y here. I'll get 0 equals 2, 3 to the x minus 18. And that's a little equation that I can solve. I could move that 18 over. I could divide by 2, and I would get 9. 9 equals 3 to the x. You can probably solve that by inspection, but we could also go to a common base, because it's an exponential equation, and then just drop our bases. X equals 2. Okay, the next part. Calculator is allowed here. The number of people living in a town is currently 2,300, decreasing at a rate of 4% per year. Find the population in 9 years. So we've got these forms of equations up here, right here. The one on the right with the a equals is the compound interest formula. The one on the left is sort of a more generalized thing. So currently 2,300, that is the initial amount. Decreasing at a rate of 4% per year. That's going to give us our base, which is 100% minus 4%. We're losing 4%. 96%, or the base of our exponent is going to be 0.96. And how long does it take for that kind of decrease to happen? It takes 1 year. So that means smiley face is 1. The time elapsed is going to be 9. So if I plug that into this formula, P equals PO, 2,300, 0.96 to the power of 9 over 1. Okay? And let's just see what we get. 2,300, 0.96 to the power of 9. Okay? 1592, you can round up if you want to 1593, or we can truncate. Either one's fine. Next one, half-life of carbon-11 is 20.3 minutes. So half-life is telling us that C is a half. When it says the half-life or the time for the half-life, that means the time for it to decay to half the amount. That's telling us smiley face is 20.3. Sample of 12 milligrams, that's the initial amount. How much remains after 2 hours? That has something to do with T, though it is not good that we're in different units here. We've either got to stick with all minutes or all hours. So I would say T is 120 minutes. Okay. And if we set this all up, we've got PO is 12, half-life 120 over 20.3. Be very careful here that you have brackets around your exponent, because you need to raise it to the power of 120 over 3. Okay. So let's plug this in. 12.5 to the power of extra brackets 120 divided by 20.3. Okay, and we just hit equals. We get 0.199 milligrams. 0.199 mg. Okay, and that is the answer. And very lastly, there's a compound interest formula question. So we've got to use this formula, and it's a little bit different. P stands for principal here, so P would be the initial amount. 9% interest. In a compound interest question, you just go, okay, R is 0.09. You don't worry about adding 1 to it. It's already in the formula. Compounded quarterly, that is telling us the number of compounds per year. So N stands for how many times we calculate interest each year. Find the value of the investment in 10 years. T equals 10. Okay. So we're just going to plug all this in. 2,000, 1 plus 0.09 over 4 to the power of 4 times 10. Okay. And again, you probably want some extra brackets here. Let's just go to the calculator. 1 plus 0.09 divided by 4, okay, to the power of, and I'm just going to figure out what 4 times 10 is myself, right? I don't need a calculator for that. So that would be to the power of 40. And it gives me 4870 roughly. And 38 cents. I hope this has been helpful. There is also a concept review for Chapter 7. Just note that we use a different compound interest formula, I guess one that has fewer variables but is a little less user-friendly in that Chapter 7 review video. So what's here might be more helpful for you in terms of compound interest. Yeah, I hope this has been helpful. Good luck with the material, folks, and take care.